Uh, Thank you, students, for today's lecture. In today's lecture, we are going to discuss about the generation or the generating circuits of amplitude modulations. Before understanding the generation of the amplitude modulation circuit, you need to know what is amplitude modulation basically. We have discussed amplitude modulation in our previous lecture and give more detail over there. So basically we can define the amplitude modulation here. So that is amplitude modulation means that you are basically varying the amplitude of the high frequency carrier signal based on the low frequency baseband signal. So basically the generation, if you said the generation is divided into two parts. The first one is square law devices. Square law modulator, and the second one is switching modulator. We will discuss separately each of these modulator. The first one is the square law modulator. As the name square law, so it means that there are some non-linear devices based on which you can make a circuit for the square law modulator. And you know that there are many non-linear devices like diodes, BJTs, FETs. So these are the non-linear devices, and the output of the square law modulator is based on the non-linear devices. And you know that the non-linear relationship is between the current and the voltages. So you can say that it is based on non-linear device. So if you wanna draw a circuit diagram, so you can say adder. The input of the adder is your baseband signal, message signal, and the other input of the adder is your carrier. So that is CT, and you know the carrier is AC cos omega CT. The other one is the nonlinear device. And after that, after the non-linear device, you are sending the signal to the baseband band pass filter. So this one is connected to that filter. So it means that V2 is the output of the nonlinear device, whereas V1 is the input of the nonlinear device. So we know that we have these two, this is input and this one is the output, and we know that the input of nonlinear device is V1t, and that is the addition of modulating signal and the carrier signal. So you can see MT plus CT, so which is equals to, like you can write MT plus AC cos omega CT. And the output is based on the nonlinear device V2 V2 is VA V1t plus V V1 square t. So that is the output of the nonlinear device. So you can see it's based on the square law. So that is why the name of this modulator is square law modulator. So if we insert the output of the value of V1, like you can see, use V1 in A. So the name of that equation is A. So the output of V2 is equals to A and T so that is equals to A and T plus A AC square cos omega CT plus B, and then you can open the square T plus AC square cos square omega CT plus 2 MT AC cos omega CT. And then you can rewrite this equation again. So that is V2t is equals to A MT plus AC cos omega CT plus B M square T plus AC square cos square plus 2B MT AC cos omega CT. And we know that the cos square omega CT is equals to 1 over 2 1 plus cos 2 omega CT. And what is the graph of the band pass filter? Band pass filter graph, if you want to see the graph of the band pass filter, so like something this. So the graph is FC. So it means that your band pass filter is tuned at a better right omega C. So your band pass filter is basically tuned to the frequency omega C, and on the left hand side it is omega C minus omega M. On the right hand side it is omega C plus omega M. So it will only allow the component to pass which has a frequency centered around omega C. If we look at the input of the band pass filter, so we see that this is a very low frequency signal, so that is why it will not pass. So this one is centered at omega C, so it will pass. So this is again a low frequency signal, so it means that it will not allow to pass. So this the center frequency is twice 2 omega C, so that is why it will again not pass. The output centered at the omega C, that is why it will pass. So after the band pass, so you can see your VOT is basically equals to AC cos after band pass filter. So cos omega CT plus 2 AC MT cos omega CT. So if you take out the common AC cos omega CT, and this one is 1 plus 2 and divided by A, and then the other one is this one again 2B. So 2B over A, and then so this is common and empty. So that is the output of the band pass filter. And we know that the AM modulator signal is written like this: AC cos omega ct, so 1 plus mu of mt. So this is the amplitude modulated signal where the modulation index mu. So the modulation index mu in this case is equal to 2b over a. So it means that we can rewrite that signal. So VOT is equals to a AC cos omega ct, so 1 plus mu mt. So you see, so this is again the same as the modulated amplitude modulated signal, and this type of signal can be generated using a non-linear device. So that device name is scale law device modulator. So today I am going to end my lecture up to here, that we have given a circuit that is the scale law modulator, and then we have the output of the amplitude modulation modulated signal, so as we have discussed in our previous lecture. So thank you for watching today's lecture. So if you have any question, you can write in the comment box, and we will answer that question very well. Thank you for watching the video.